Asset performance does not improve by accident. If you manage complex assets, you already know this. Performance improves when structure, data, and engineering discipline come together. Asset reliability as a service is about creating a reliability framework that helps your assets perform better consistently. Predictive maintenance can typically result in a 10 to 20% reduction in maintenance costs and a 20 to 50% reduction in unplanned downtime. Most organizations already have a strong team, SCADA systems, and CMMS in place. What is often missing is a clear reliability backbone, a structured way of linking asset hierarchy, failure modes, maintenance strategy, spare parts, and performance data into one coherent system. ARaaS provides that structure. Most maintenance strategies focus on detecting failure early. ARaaS goes further. We shift left of the PF curve, mitigating the conditions that cause failure before degradation even begins. It starts by clarifying your asset hierarchy, defining what should be maintained, at what depth, and why. Not every component needs the same level of attention. We build a practical structure, aligned with how maintenance is actually executed. This improves traceability, reporting, and decision-making immediately. Next, we align maintenance with real failure behavior, using reliability-centered maintenance principles. We identify how equipment fails, what drives those failures, and which interventions genuinely prevent them. The result is focused maintenance, less unnecessary work, and effort directed where it adds the most value. In practical terms, this makes a measurable difference. For rotating equipment, for example, small inefficiencies, misalignment, imbalance, or bearing degradation increase energy consumption long before failure occurs. By detecting those patterns early and intervening at the right time, energy draw is reduced and equipment runs closer to design efficiency. In process plants, minor pipe leaks and valve degradation often go unnoticed because production continues. Those losses accumulate through energy waste, pressure drops, and increased pump load. With structured monitoring and failure mode-driven inspections, these issues are identified early, reducing energy waste and extending equipment life. ARaaS also connects operational data to engineering decisions. Through predictive analytics and condition-based rules, we detect degradation trends and abnormal patterns before they become operational disruptions. Teams can plan interventions calmly and deliberately, rather than responding under pressure. Spare part strategy is designed into this framework. Instead of holding excess stock just in case, we link inventory directly to known failure modes and maintenance plans. Critical parts are available when needed, while working capital remains controlled. For senior engineers and asset leaders, the value is clear. Higher availability, lower energy losses, reduced lifecycle cost, more predictable performance, and clearer visibility of technical risk. Consider a renewable operator transitioning to self-performed maintenance. With multiple vendor coding systems and no unified structure, scaling becomes complex. ARaaS establishes a consistent coding backbone, defined maintenance depth, and structured spare alignment. The result is operational control and confidence as the portfolio grows. Asset reliability as a service is not a one-off study. It is a continuous cycle. Strategize, deploy, monitor, optimize. Asset reliability as a service. Engineering reliability with clarity.